Good morning to one and all. I am very happy to be a speaker for this online webinar on wave optics. I am Allam Mallikarjun, Associate Professor. I received my MSc from SV University and MPhil from Annamalai University, Chidambaram. I have been pursuing my PhD from Geetham University, Vizag. I have been backed 18 years of experience in teaching and administrative field. At the outset, I would like to extend my sincere thanks to our chairman, Dr. Vanki Penchalaya Garu, and beloved director, Dr. A. Mohan Garu, and freshman engineering department, HOD, Dr. Y. Arnath, and Dean C.H. Suresh Garu, for having given me this wonderful opportunity. Today, I would like to discuss about wave optics. In wave optics is generally three parts: interference, diffraction, polarization, and fiber optics. In generally, so some of the contents of interference is principles of superposition, interference of light, and conditions for sustained interference, interference in thin film by reflection, Newton rings, determination of wavelength, and determination of refract index for liquid, and some of the engineering applications. The first one is, so what is meant by interference? So what is the interference is the modification of intensity due to the superposition of two or more coherent light rays. In the before, I would like to discuss about the interference. Optics is the study of behavior of light is subjected of optics. Light is a form of energy that produces the sensation of vision. Light occurs invisible when it falls on an object. The scattered light enters the eye and the object becomes visible. So, in the diagram is the sunlight is visible of all the directions from like space regions, x-axis, y-axis, and z-axis. Another one is, this is called normal light. It is incoherent light. The incoherent light is spreading from throughout all the directions. Another one is, so this is called laser light. Laser light is a polarized light, and it is also coherent light. It transfers all the directions. So its properties are classified into three categories. One is called geometrical optics. Another one is, it is a geometrical object is a reflection, refraction, and refraction. Another one is dispersion. So a physical optics is like interference, diffraction, and polarization. The quantum mechanics is like lasers and non-linear optics or non-linear effects. But basically, what is the reflection? What is the refraction? So reflection is the process of sending back the light rays which falls on the surface of an object. That means when the incident light falls on any obstacle, the light is reflected to the reflected direction. That means theta I, theta R. Another one is refraction is a bending of light when it passes from one medium to another medium. And from the diagram, so the air medium to it move from some other water or glass medium. The incident light ray travel from the denser medium to rarer medium. So nature of light. Light is a form of energy and energy can be transmitted in the space. It is a two types, actual motion of the particle, that is a particle motion. So the particle is the dispersion of the light from one place to another place. The particle has a definite mass m, velocity v, momentum p, the kinetic energies of m e square. And particle is the wave motion. The wave is spreading from the one place to another place. It is not a located region. The wave is continuously passing from the x is equal to one place to another place in continuously space regions. So what is the basically the intensity of light from a small source follows an inverse square law. So the difference between the dual nature of light, the light is the difference is the particle and wave. The difference is the particle has a mass and it is located the definite point. It can move from one place to another place. Particle is specified by mass, velocity, momentum, and energy. And particle is continuously moving from one place to another place with the velocity v. The wave is spreading from the overlong the distance. It is a large region of space and it cannot be said to be a particular location. So it is spread out by some frequency, wavelength, phase, amplitude, and intensity. From the diagram says the particle is a definite mass and wave is it is not a mass, it is spreading from the one place to another place in continuously. So according to Huygens Fresnel, the light propagate in the form of mechanical waves through the either medium, and this theory successfully in the interference and diffraction patterns. So wave is a periodic distribution in a medium which propagates with a time from one place to another place. We know that waves spread in the form of crust and trough. So here I ripple the water in continuously forming crust and trough waves. So in between of one crust, another crust, the difference is of wavelength. The wavelength may be defined as any two successive crust or any two successive trough. It is known as wavelength. So the transverse waves, if a particle of the particles of the medium oscillates perpendicular to wave propagation, that waves are considered transverse waves. The transverse waves is continuously moving from the perpendicular wave propagation. Another is it is a ripple produced on a water surface. So continuously the ripple the water forming crust and troughs in continuously. So waves produced on a rope, it is the best example of the production of waves. Longitudinal waves, if the particle of the medium oscillates parallel to the wave propagation, that waves are considered as a transverse propagation. So the transverse propagation, that atoms are moving from the one place to another place, the vibrations is, it is a parallel propagation that is called longitudinal wave propagation. So the sound waves in air, the waves produced in long horizontal springs. So wavelength, the distance between any two successive crusts or any two successive troughs is called the wavelength. The amplitude is the maximum displacement of the vibrating particle from its mean position. It is known as amplitude. The phase is the phase of vibrating particle at any instant is the state of the particle as regards its position and direction of motion at that instant. So here, the wave 1, wave 2, you have observed the particular diagram. So it is a constant phase, constant frequency at that moment. So another diagram is wave B. One is a positive cycle, another is a negative cycle. That means it is opposite directions. that is y is equal to y1 minus y2. It is a descriptive interference. That means the two waves 180 degrees out of the phase. And the phases is, there is no phases, it is called constant phase. That means it is a constructive interference. If the waves maintain constant or zero phase difference, that waves are said to be in phase. If waves maintain the phase difference phi, then the waves are said to be out of the phase. According to principle of superposition, when two or more waves travel in the simultaneously in a medium, the resultant displacement at any point is due to the algebraic sum of two individual displacements. Here, y is equal to y1 plus or minus, y2 plus or minus, y3 plus or minus, and so on. The positive sign has to be taken when both the displacements y1 and y2 are in the same direction. The negative sign has to be taken when both the opposite direction. For example, when two stones are dropped at different position in still water, the expanding ripples pass through each other without any mutual effects. So in the diagram is, so it is a waves are continuously produces like crust and troughs are bright and dark rings continuously. So interference, what is meant by interference? When two or more coherent light rays traveling in the same direction, constant phase, constant frequency, the modification of intensity due to the superposition of light waves is called interference. The interference best example is soap bubble and floating oil films. So another definition is the modification of intensity obtained by superposition of two or more waves of light. It is known as interference. The resultant intensity at any point depends on the amplitude and phase relation of the waves. So to observe the diagram is, it constantly the phases are both are in the positive cycle, that is y1, y2 in the positive manner, that is called constructive. Out of the phase in 180 degrees, that is called descriptive interference. Constructive interference is if the resultant intensity is greater than separate intensities, that interference is a constructive interference. And descriptive interference is if the resultant intensity is zero, less than the intensities of individual waves, then that interference is a descriptive interference. To visualize the phenomena of interference, consider the waves produced on the surface of the water. The ripple the water, it continuously forming crust and trough waves are constructive and descriptive interference. Let us consider a wide water tank with two water taps and just the taps so as to make the water drop to fall from both the taps simultaneously. The points S1, S2 on the water surface acts as two sources of waves. If the water drops are of same mass and falls from the same height, waves of the equal amplitude spread out as expanding circular waves or wave fronts from S1 and S2. That means in the region where both the waves superimpose, we have to apply the superposition to find the resultant displacement. Y is equal to y1 plus y2, that is called constructive interference. Y is equal to y1 minus y2, that is a descriptive interference. In the diagram is the interference pattern. The source of light is spreading from the single state. It continuously it is forming of S1, S2. Here, continuously or dotted lines is forming constructive and descriptive interference. That means the center of the spot is the brightness and alternate forming of bright and dark films continuously on the screen. Coherence. Coherence is if the waves maintain constant or zero phase difference, it is known as coherence. Coherence is a two types. One is the spatial coherence and temporal coherence. If the waves maintain phase difference phi, then the waves are said to be incoherent waves. So in the diagram is a combined waves and individual waves. So out of the phase 180 degrees out of the phase, that is the descriptive interference. To observe interference, two light waves should be coherent, and temporal coherence is if the waves maintain constant phase difference at a point on a wave with respect to another point on the same wave, then that waves has a temporal coherence. And spatial coherence is if the waves maintain constant phase difference at a point on a wave with respect to another point of another wave, then the waves has to be spatial coherence. So maximum intensity condition and minimum intensity condition, if the phase difference delta is equal to 0, 2 pi, 4 pi, 6 pi, and so on, 2n pi, where n is equal to 1, 2, 3, and so on. Delta is equal to 2n pi, that is n is equal to 0, 1, 2, 3, and so on. The path difference delta is equal to 0, 2 lambda, 3 lambda, 4 lambda, and equal to n lambda. The minimum condition is if the phase difference delta is equal to pi, 3 pi, 5 pi, that means 2n plus 1 pi, 2n plus 1 pi, then delta is equal to 2n plus 1 pi, n is equal to 0, 1, 2, 3, and so on values. If the path difference delta is equal to lambda by 2, comma, 3 lambda by 2, comma, 5 lambda by 2, comma, and so on, that is equal to 2n plus 1 lambda by 2. So what is the conditions to observe the suitable interference is the two light sources emitting light should be coherent. The two sources must emit continuous light waves, same wavelength and same frequency. The separation between the two sources should be small. The distance between the two sources and screen should be large. The amplitude of the light waves should be equal. The sources should be narrow. The sources should be a monochromatic light, and their waves must to travel in the same direction. So these are all of the conditions of interference. What is the division of wavefront and division of amplitude? So division of wavefront and division of amplitude, in this method, the wavefront originating from a common source is divided into two parts by using mirrors, prism, or lenses, and the two waves fronts, the separated travel and finally brought together to produce interference. An example is Young's double-slit interferometer, Lloyd's mirror, lasers, Fresnel by prism. And division of amplitude is, in this method, the amplitude of the light is divided into two parts. One is called reflection and refraction. Thus, we have coherent beams produced by division of amplitude. These beams travel different paths and are finally brought together to produce the interference. So here, the air medium to light is passes to the, like in denser medium to rarer medium. Then the light is reflected to the same direction. These reflected light get superimposed to each other, it forming interference pattern. The best example is interference in thin films, Newton rings, Michelson's interferometer. And interference due to thin film by reflection, according to it is based on the division of amplitude. Different colors are observed when the sunlight falls on the soap bubbles and thin film of oil on water surface. Then different colors were observed. This is due to interference. The similar color phenomena is also exhibited by thin glass plates and mica sheets. So the diagram is, it is a multiple colors of soap bubble. It is a floating oil film in the earth. And the interference in the thin film is due to either reflection or refraction of light rays from upper and lower surface of the thin films. So the flying of air bubbles from in different colors, the sunlight in the view of soap bubble, the colors is observed in multiple colors of the soap bubbles. The interference due to thin film by reflection, according to, if you take any two glass plates like A, B, another is C, two glass plates. In between the two glass plates, the air film is thickness is T and refractive index is mu. Let us consider a transparent plane parallel thin film of thickness small t with refractive index is mu. So let a monochromatic light of incident light rays PQ, an angle of incidence is I on the upper surface of the film. QS and QR1 are the reflected and transmitted light rays, and the angle of refraction R. Then the light rays QS will be reflected into the film and emerging through the film in the form of light ray UR2. These two light rays superimpose, and depending upon the path difference between them, they produce interference pattern. We know that the path difference, let us draw the normal NQE, FS and UG from the points of U and G, the light rays travel equal distance. Then in forming of some mathematical calculation, the finally you get the value like in 2 mu t cos r is equal to n lambda. It is a mathematical derivation like in 2 mu t cos r plus delta is equal to 2 mu t cos r. That is the phase difference is 2 mu t cos r plus or minus lambda by 2. The plus or minus lambda by 2 means the incident light and reflected light both are out of the phase. That means 2 mu t cos r plus lambda by 2. So the net optical path difference is delta is equal to 2 mu t cos r plus lambda by 2. According to condition is a maxima condition. The maxima condition is if the path difference delta is equal to n lambda, where n is equal to 0, 1, 2, 3, it is a constructive interference takes place, and then film will appears bright band condition. And minimum intensity, the path difference delta is equal to 2n minus 1 lambda by 2, the condition for darkness of the reflection. So this is called the maxima condition and minima condition. So the minima condition is delta is equal to 2n plus 1 lambda by 2, and corresponding the simplification in mathematically 2 mu t cos r is equal to n lambda. So the condition for brightness of the reflected light. So Newton rings. So the Newton rings class, so next class I would like to discuss with you.